Welcome to this edition of the Alaska TTAP webinar series. Billy Connor, who is the director of the Arctic Infrastructure Development Center and the Alaska Tribal Technical Assistance Program at UAF, will be presenting today on managing fugitive dusts on roads and airports. This is the first of a two-part presentation that Billy is doing. The second part will be presented on May 23rd. That is a change in date from what was announced in the first mailing. But the second mailing had the correct date, and more will be mailed out about that second webinar in this series as we get closer to the 23rd. Billy has a great deal of experience with first the Alaska Department of Transportation and Public Facilities, as well as then moving to the university and being involved in transportation research and projects for a good many years after that. And so I will turn you over to Billy. Take it away, Billy.
Okay, thank you, Vicki, and welcome to all of you who are joining us today to talk about dust. I know it's a very high concern throughout Alaska, both in the villages and even some of the other areas around the state. I live on a gravel road, and I certainly feel your pain every time someone goes by. My house is full of dust, and we're constantly cleaning up to keep the dust down within the house. So I certainly feel your pain as we go through this. So we're going to be talking about a number of different things today, and the focus of today's effort is really on how dust is formed, how we can manage it, and we're going to assume pretty much for today that the roads are all gravel, or as we sometimes call them, unbound surfaces. And we're going to talk about understanding the fugitive dust. The dust is coming off of our roadways, and in this case, the photo airports, the impacts of those dust, how they affect our daily lives, how can we manage it, how we manage our roads in order to minimize the dust, as well as selecting the right palliatives and how we apply them, and then talk a little bit about some of the tests that we have available to test the performance of our palliatives before we even put them on the roadway, so that you can get an idea of some of the resources that are available to you. Right now, throughout the U.S., there's 1.3 million miles of unpaved road. 97%, as you might guess, are in the rural areas. And the data that we've collected over the years indicate that there's about 10.5 million tons of particulate matter, PM10, as we know it, to 10 micron size, being put into the air on an annual basis. So that's a lot of material that's kind of floating around in our air and impacting our daily lives. To bring it home a little bit, I consider a 2-mile road of unpaved road, which is not uncommon for many of our communities around the state. 20 vehicles a day at average speed of 30 miles an hour. If we do that, we're putting about 5 tons of dust per month into the air, and that's getting into our lungs, getting into our houses, and just wreaking a bit of havoc with that. So that's kind of gives you the magnitude of that, and the photo that you see there kind of gives you a sense of what kind of. It's interesting to note that an ATV puts about the same amount of dust as that pickup that's coming at us or going away from us in dust each time. We'll see some photos of that, but just kind of think of an ATV instead of a pickup there, and you'll see about the same amount of dust being thrown into the air. It does have an impact, degradation of the road surface, and we'll talk a little bit about how that manifests this stuff in there. Driver safety, primarily due to the washboarding and to the visibility in there, and then the health and quality of our life, and especially the elderly and the young are really affected by that quite a bit. Just make sure we're all speaking the same language in all of this. I'll give you some definitions, and we'll give you a few more as we go along. The surface course is the top layer of the road that is being driven on. And that can be anywhere from uh, silt. Some of you have dirt roads out there, all the way to gravel roads, chip seals, and even pavement. So the surface is what's on top, basically. Aggregate is a mixture of rock and sands and silts that make up the road surface. Fines, that's that fine material that makes up the dust, if you will. And we actually can use that to our advantage, and we'll talk about that a little bit in there. Plasticity, that's kind of what makes everything stick together in there. Most time we think about clay, but even some of the silts have a stickiness to it, if you will, and we call that the plasticity of the soil. And we actually want some of that in our soils to make it dust free. A dust press suppressant or dust palliative, we use those interchangeably, is the substances that we apply to our surface to reduce the dust, the generation dust. And then chip seals or high floats, that's a type of road that's made up of one or more layers of asphalt and aggregate. And of course, we all know what a hot mix pavement is, and we'll talk about that. Chip seals and high floats and those types of materials in part two. Okay, a few more definition. Loftable material, that's material that can be placed in the air due to wind or vehicles going by. That's usually the 75 mm size material, that 0.75, I'm sorry, material is in there and finer. And that you can see that in the photo off the Dalton Highway here. As a vehicle, actually there's two vehicles going by there. If you look carefully, you'll see a bus going north. But at any rate, we can see that. Suspended material is one that stays in the air for an extended period of time, and that's usually the PM30 and smaller. The smaller it gets, the longer it stays in the air, and we'll talk about that. And then those materials that are harmful to the health, those are smaller than PM10. Sometimes you hear about PM2.5. Those are the materials that actually get into the lungs and cause damage to us. And we'll talk a little bit more detail about that. So looking at that, we can define the dust in a few different ways. We're going to talk about the heavy dust. That's the material that is fairly large in size, and that usually falls out of the air very rapidly within a few seconds, 3 to 4 seconds in there. And then there's the settling dust that usually falls out of the air in about within 30 seconds. And then there's that's suspended in the air, which is kind of in the 2.5 PM 2.5 range. That can stay in the air for days. And in fact, at times if you look in the air, you can see haze forming in there. Some of that is due to fog or water, but some of that is due to the fine materials in there as well. And that can stay, as I say, in the air for days. And we actually get a fair amount of dust through that transport all the way over from Russia. I kind of put it in perspective. We've got a 50 micron size of a human hair. Um, Unfortunately, I don't have much of that, so I can't really tell you what's like to have that size. But the PM 2.5 or PM10 is about one fifth of the size of a hair. And if you go look at a PM 2.5, it's a quarter of the size of PM10, which would be about 1/20 of the size of a human hair. So we're talking about some pretty fine material in what we're looking at. As far as the health issues, as I said, it impacts children and elderly most likely due to emphysema and the sensitivity of young folks' lungs in taking up that. There's been some studies um, by the World Bank that indicates that the mortality rate um, actually goes up to about somewhere between 4 and 10%, depending on the base health of the community, for the 10 micrograms per meters cubed, which we can get in there. The photo was showing that is much higher than that. So we can actually see the mortality rate going up a little bit due to dust. It also gets in the alveoli of the lungs, reducing the transfer of oxygen. That's where the emphysema and comes into play in that. And if you get the materials that are 1 micron or smaller, it actually can enter the bloodstream. And some of the studies that we've done with the equipment we've got here at the university, there is some of that material in the air that's coming off our roadways as well. Uh, One of the things that we really need to pay attention to when we're talking about dust and the dust suppression, we need to start prioritizing where we're going to use it. Uh, we can't, in most cases, you can't afford to to eliminate the dust in your community. So we want to put it where it's going to be most effective. And that's generally where the use is highest, where the traffic is highest, and people are going. But we also want to pay attention to the areas where people tend to congregate, like the school, the community store, clinics, those kinds of places, especially where we have young and elderly uh, congregating. We need to prioritize those outside our homes where people who live with respiratory issues is a good area to pay attention to. There are maybe some areas that are environmentally sensitive in or near your community, perhaps fish passage and some of those kinds of things, or where you pick your berries would be a good one. Um, and then roads near subsistence and food preparation areas. So, looking at this, I'm sure you've all seen this as in the communities as you drive around. So let's talk a little bit about how that forms. When a vehicle goes by, you're getting shear from the tires, which is kicking up some of the dust. And if you carefully watch when a vehicle's going by, you'll see that going through there. And then coming off the back of the vehicle, we get what we call turbulent shear. That's where the air is mixing very rapidly, and it just kind of picks it up. So as the vehicle goes by, that shear goes from the air will likely pick dust up off of the surface and kick it up into the air. So we call that a roll-up flow. And then as the vehicle goes by, there's some vortices that are created in the air. The air is still moving and kind of swirling around back there, which holds the air up in there. And if you look in the front of that van, you can see there was another vehicle that goes by there, and that really fine material can be carried for miles away from the roadway and stays in the air for a long, long time. Um, the movement of dust, there's several parts to that. There's the mechanical and convective air lofting, just the heat of the air can actually, once it's lofted into the air, I can hold it in the air and move it up. And that, so if, on a very hot day, you'll probably notice that the dust goes much higher behind the vehicles than it would in, say, the cooler areas. So that's the convective lofting. And then there's advective, that's just movement of the dust as a result of the air movement or the wind movement, moving it in the direction of the wind. And then oftentimes there's some turbulent flow up there going on that kind of swirls around and holds it up in the air. And you've seen those, you can see that sometimes in the air movement due to plumes of smoke. Look at the stack during the wintertime coming out of your furnace, and you'll see some of that turbulent flow going on there. And then finally, it settles out. So you can have a number of different things going on there that help hold it up, and that have an impact or not. It's not horribly important that you fully understand all of this, but it's kind of nice to know what's going on and why the dust is going the direction that it is. Uh, I'm going to push the button here in a minute just to kind of give you a sense. And these are actually to scale for the particles, all the way to from the 0.1 millimeter down to a 0.001. The 0.1 millimeter stays in the air about 3 seconds. It comes out very rapidly. That's you can see that behind the ATVs as they go by. You'll see that dust just kind of just falls right out. Um, but some of them fall, or the 0.1 micron, the stuff that I said get in the bloodstream can stay in the air for 6 hours or more. And so it can be transported a long, long ways. And if there's any of that turbulent flow that we just talked about, that can hold it up in the air for days or even weeks as the airflow gets it high enough. And we can see dust up at the 10,000 plus foot level at times, just due to all of that. So if you watch this, you can kind of get a sense of how rapidly those particles fall in relation to each other. As I say, it's all to scale, but certainly I don't want to wait 6 hours to let you watch that particle fall. So it gives you some sense of how that comes about. Okay, so let's talk a little bit about methods that we can use to manage dust. And we generally want to start with the cheapest first. Um, but at the same time, it turns out that the best dust management programs that we have really starts with the roadway itself. We want to make sure that we put the road together in such a way that we minimize the dust that's being picked up off of it. And there's a number of things we do. But before we get started, some more definitions for you. The traveled way is the area which the vehicles travel on or people walk. And then there's the shoulder, which is just off of the edge of the traveled way. Sometimes we don't have much of a shoulder. In other cases, we do have a lot of shoulder. The foreslope is a slope on the front, at the edge of the embankment. And then sometimes we have a ditch, sometimes we don't. It's always a good idea to have good drainage. We can talk about that. And then we have a crown, and that's the difference between the center line and the edge of the road. We need some of that going on there. And then we have the back slopes there, which is the back of our ditch. And then the right of way is the portion of the roadway that's a portion of the land is dedicated to our roadway network. So this is something that we put together a few years ago, which has been, I think, fairly helpful for people. And this is suggested Dutch management approaches that we have. Um, this is not cast in very rigidly, but it gives you a range of or a sense of ideas what you might be looking at. If you've just got a few days, 10 to 20 days a year between May and September, that uh, have dust or dusty, you may want to consider institutional controls such as changing drivers' behavior, speed limits, those kinds of things. And that also, if you want to look at it on the road uses, less than about 25 vehicles per day. If you're down in that range, it's going to be more effective for you just to simply try to keep people slowed down and use those kinds of institutional controls. If you get up between 21 and 30 or so, we probably want to start institution control plus water. Water is a very good dust palliative or dust suppressant. It just doesn't last as long as some of the others do, and we'll talk about that in just a bit. Or between 25 and 75 vehicles per day is kind of the range that you might want to consider for water. Once you start getting up 30 to 50, you probably want to start adding some chemical stabilization or palliatives in there. We'll talk about what those look like. And that gives us a range of about 75 to 500 vehicles per day. The range is getting a little bigger here. And then if we get in the order of 50 to 60, we're probably going to be talking about um, using some sort of aggregate stabilization, such as chip seal pavements. There's some other materials we'll talk about in part two on that. And that's in the range of 500 to 1,500 vehicles per day for chip seals. And if you want to get over about 1,500 vehicles per day, probably going to be talking about pavement in there. So it kind of gives you some sense of what types of strategies that you may want to use. Many of our villages are in that 25 to 75 range, maybe just a little bit more than that as far as number of vehicles per day going through there. Fines, remember that's the minus 0.75 of the 200 sieve. going in there. We want that to be up in the range of 8 to 15% for untreated roads. In fact, we want that up there for treated palliatives as well. And it probably sounds a little bit counterintuitive to you to add dust in order to reduce dust. It's because that dust being put in there acts as a binder, if you will, and holding the coarser aggregate together and reducing that dust. And it does work. I can attest to that, having done that a number of times. Adding a little bit of fines will help that. And this, all the specifications for surface courses for unpaved roads will give you the fines content somewhere in that range. They'll vary a few percent one way or the other in that. I know Alaska DOT really likes it more in the 10 to 16 or 18% fines for their purposes, a much bit higher volume, but that's the kind of range you want to go. So if we look at this in a little bit different terms, think of the shrinkage product as the plasticity index, which gives you a sense of the stickiness. The more sticky that it gets, the better it's going to bind together. And then the grading coefficient is the amount of fines in relationship to the coarse aggregate in there. And I'll show you a little graphics of what that means. But if you get too many fines in there, it's slippery and dusty. It's not binding together very well. If you get in that kind of that mid range, but if you get too low of fines in that shrinkage product or the stickiness of it, it becomes erodible. But if you get too high, it ravels, and you've seen that. And I'll show you some photos of that. You get a lot of gravel on the surface. But if you get it put together right, you get that sweet spot where everything hangs together real well. If you don't have enough fines in it, or you don't have enough of that sticky material, that clay material, you're going to get washboards and raveling in that. So the point of all of this is you've got to get that gradation right so that you get the optimum on there. I know in the villages, you often don't have the resources to do that, but to the extent possible, you want to try to find yourself in that good area as best you can. Here's a situation where there were too many fines, and I'm sure we all seen this, where you get um, muddy areas, fine areas, and then when that dries out, it just turns to a dusty mess, and even walking through it casts up a lot of dust going through there. If you don't have enough fines, we end up with something that looks like this. And so if you see something like that, you're pretty well assured that you don't have enough fines. We call that aggregate float, and that just gets cast off to the side. And unless you find a way to put the fines back into that, you're just going to lose that material. Um, this is kind of an interesting photo. It's here in town in Fairbanks, one of our local roads. You can see the float there. That indicates there's not enough fines. You also see the washboarding going on there, and that has to do with the frequency of the tires as they bounce along the road, causes that, and that's a function of the speed as well as the suspension characteristics of the vehicle. And if you look over there, oftentimes off to the side, you'll see a layer of fine, loose fines there. And when people drive over there, you really get a lot of fines being cast out. And when you have that situation, you're losing your aggregate. So it's not only costing you in the way of health effects, it's also material that's being thrown away and cast off to the side, and that you're going to have to replace it a fairly significant cost at some point in the future. So let's look at what's going on in there. The photo or the graphic on the left side is aggregate with no fines in it. There's nothing holding it together. It's just you're getting grain to grain contact, and under the right conditions, it's pretty strong, but it's variable in density. It's not frost susceptible. That's the good news. But there's not a lot holding it together, and you can't really compact it, and it's going to ravel. You're going to end up with a lot of float in there, and it's just not going to hold together very well. And you're going to get a lot of cracks in your windshields if you got windshields, and if you don't, if you're on a four-wheeler, you can get rocks thrown and they hurt when they hit you. If you get it right, you're going to maintain that coarse aggregate grain to grain contact, and you're just going to fill the voids. And those voids kind of help hold it together in a number of different ways, especially if you got a little bit of clay in there, which makes it work out pretty well for you. That's the ideal situation. If you get too many fines or too many fines in there, you start to see those fines separating the aggregate in there, and it's just kind of floating around in there. It ends up being frost susceptible. It's not very strong. It's low stability, and you're going to find that that material will produce dust very readily because the tires can actually get access to the dust itself or to the fines itself and start casting that out. So it's the middle range of the gradations you want in there. I didn't put it in this presentation, but there are some equations and some tools that are available to us that help us look at the gradation and determine whether we're in that sweet spot or not. As I say, um, it's important to get that gradation correct. We also want to make sure we get a good crown. And I know that most of the communities I go out, they either have no crown or they have a belly in the road. And I'm not going to go into the details. I think hopefully some of you were in attendance at our gravel roads workshop about a month ago. We went over to some of these things in detail, in great detail in that course over a couple of days. But we really want our crown to be about between 4 and 5%. If we don't get it enough crown in there, we get something like this. You get a lot of ponding, you get a lot of potholes in your roadway, and so that's not a very good situation for you. And it'll also, because the water as it goes through something called pumping and hydraulic action will actually force the fines out of the soil, and it'll end up on the top and just to be blown away. So that's what forms the potholes is that the tires hit those potholes and force the water out from under them, and when they do so, they take the fines with it. If you get too much crown in there, you end up with erosion, as we see here. Uh, and that's not a good situation either because you're just washing your fines out of them and over into the ditch. And you're losing that material. And it also makes it rough, and you're going to have to grade it more often. And every time you grade it, you lose a little bit of material, which is not desirable either. Some really nifty little tools that you can do. This is called a slope meter. You can either put this on a 2x6, a nice straight 2x6, and lay it on the road and measure the slope that way. Some people actually put it on their grader or on their vehicle, and as they drive up and down the road, they can see what the slope is. Just make sure that you put it when you put it on, it's on a nice flat surface that is you know what the slope is so that you put it right configuration. But these things are about $300. They're not hardly expensive for you, but they are a great tool. I like to put it on the grader so the grader operator knows what they've got as they are doing their grading, and there's no question about what they have. Another tool is just simply cut yourself a batter board, about 1/2 to 3/4 of an inch per foot, and you just lay that on the roadway. What some people do is take a 2x6 and put a level on it, and then um, lift one end or the other by the amount that's shown here, and use that as kind of a homemade slope gauge for you, and that works out quite well. And it is a fairly inexpensive way to do it, and you can do it generally with materials that you have on hand. Um, One of the things you can do is pay attention to how your grader's doing. This is a great photo. It's about 90% right. Uh, they suggest, grader operators suggest if you've got an articulated grader that you articulate it a little bit to make this a little bit easier. But if you look at this, there are a number of things to watch up there in the left-hand side that the material is feathered. You don't want any any berms along the road to hold the water. So that's laid out very nicely so that the water can run off. Um, as the grader's going by, if you'll look under the center line edge of your blade, you should see a little bit of a gap as it goes past that center line point, as you see here. And the blade is rolled forward. And the other thing you want to do is take a string line and string line your blade once in a while and make sure it's nice and straight so that it's not either convex or concave, but usually you end up with a belly in there, and so you're creating kind of a quarter crown in the middle of the area that you really don't want that. You want it to be nice and flat. And I'm not going to go into the great detail about how to operate your grader. We can do that at some other point, and maybe Vicky will reschedule the gravel roads here in the not too distant future, so a few more of you can attend that. Looking at the dust, one of the most cost-effective things to do is just simply, especially in areas where you have people living, areas where people congregate, just slow down. This is a great photo of pickup at 15 miles an hour. It's kicking up a little bit of dust, but it's not really being lofted to the point where it's causing a problem. Just by doubling the speed there, you can see that's a huge difference. You can hardly even see the pickup anymore going through there. And I didn't use it in here, but we also repeated this experiment at 45 miles an hour, and you couldn't even see the road at all in that dust. So just simply slowing down. We recommend about 15 miles an hour in the areas where you have people congregating in order to keep the dust down. And this is on a very dry day. So you can see even on dry days that it's helpful, just simply slow down. If you look at the air temperature, the warmer that is and the drier the air is, the more dust you're going to get in here. So it just shows on the left-hand side the amount of dust going in there. Don't worry about the numbers too much. Just look at the shape of the curve and the air temperature. As it's getting warmer, you're just simply putting more and more dust into the air, and that's so it's you probably want to slow people down more in the hotter, drier periods than the cooler and more wet times of the year. So those are, kind of gives you some idea what's going on. And please, if you have any questions, put them in the chat box, and Vicky will monitor that. And if there's some questions, she'll stop me, and I'll be happy to answer those questions. Uh, the last time I looked, which has been a couple of years, and I know there's a few more out there now because I've just got a call from a vendor a few days ago and telling me that he's got this wonderful new product that he would like us to test, and we've agreed to do that for them. But there are about 250 of those out there, probably about 275 by now out there. They kind of come and go out there, but we break those down into some categories, and I'm just kind of going to quickly go through those, and I'll indicate which one of them have been most commonly used in Alaska. If anybody outside of Alaska, you may use some of the others that we don't tend to use up here, and I'll kind of go walk through these as to when to use which ones. Water is always a good one. As I say, one of the problems with water, especially in a hot, dry climate, it does tend to go away fairly quickly. It's just the nature of water. That's something really. Water attracting salts, calcium chloride, magnesium chloride, sodium chloride, and there's some potassium chloride. There are several of these chlorides that work or salts that can be used. In Alaska, calcium chloride is the one of choice because it seems for our climate and our situation, it works really well. And we use it for ice control as well. So we just tend to use one product. Magnesium chloride is another heavily used for dust control, especially in the lower 48. Magnesium is generally the one of choice, and it works out quite well for them. A bit more expensive than calcium chloride, but in the lower 48, so they don't have the shipping to deal with that we have to deal with in keeping those costs down. Alaska DOT uses a lot of calcium chloride in their roadways, the Dalton Highway, the Taylor Highway, and a few other highways that they have. They use calcium chloride for that. Organic or non-bituminous materials like lignin sulfonides, tall oil, pine tar, even vegetable oil. And I'm going to say I wouldn't use vegetable oil. It over time it turns into dust itself because the sun, uh, the UV light causes it to turn into a brittle material, and then that breaks down into a small particle size, which ends up being part of the dust. And we have no idea how that affects our health. And so I tend to avoid that one. But lignin sulfide, tall oil, and pine oil, they do work well. It's very common in some lignosulfonides, sulfonates, sorry, um, is very popular in the South because they have a lot of pulp and paper mills down in the South that they it's a byproduct of the paper industry, so they've got plenty of it, and it's fairly inexpensive for them to use as part of that. Tall oil is used. Sometimes it's mixed in with synthetic fluids, which we'll talk about in a moment. And that's just the pitch from pine trees that comes out of that. Synthetic oils, they're proprietary formulations. They're generally made from petroleum products, either crude oil or natural gas. They're not refined per se. They're actually chemically altered to take all the volatiles out of them so that we don't have to deal with benzenes and all of those. Very effective. I mean, we do use a fair amount of that in Alaska, especially on our gravel airports. Some of your villages, DOT maybe have come, or is likely to have come to the village to put synthetic oils on the roadways or on the airports to keep the dust down in those areas. A bit more expensive than calcium chloride, but they are non-corrosive. That's one advantage of it. We'll go into calcium chloride in quite a bit more detail in shortly. Chemical stabilizers, enzymes, sulfonated oils, and ionic materials. Um, those are commonly used. They use primarily for various types of clays. Not horribly effective in Alaska unless you're in an area that has clay. Uh, if you hear anything, have any materials that being suggested that ends in zyme, like permazyme and some of those EMC squared, some of those materials, they're generally enzymes and they work really well in clays. But if you don't have clays, they're not quite as good and don't work quite as well for you. Bitumen, asphalt, tar, those are fairly common in pavements, chip seals, compact. You can apply emulsified asphalt as a palliative directly to the aggregate. Most people don't like it because while it's curing out, it ends up getting on your vehicles or on the kids or whatever, and it's a little bit difficult to get off. Synthetic polymer emulsions, polyvinyl acetates and vinyl acrylic, they are very good materials for the purpose of making a hard road, and I have used them as soil stabilizer. In the lower 48, they use it in mining areas to keep down the dust in their waste piles. And in some places, they use it on coal to keep it from blowing in train cars. And in Arizona, they put it down on a regular basis in subdivision roads in order to keep the dust down. They just topically apply it, and they can actually get a couple of years out of that doing that, and it makes a nice hard impermeable surface that water does not penetrate. So it is an option for you. Some considerations when you're looking at dust suppressants. First, you want to plan, assess, prioritize, and budget. You really don't want to just go out there and randomly put this stuff down. It's fairly expensive for you, and you want to put it to where you're going to use it. But you really should start your planning process early, like September, and you should probably order your material before in sometime in the November, December time frame. You want to look at your roads and see which ones are ready and what you need to do to them in order to make them work. And then, as we've talked about prioritization, put it where the people are and where you have sensitive populations. And of course, you got to pay for this somehow. So you need to create a budget for that. And we'll talk a little bit more about all of these as we go along. One thing we always want to do is start with a good base road, and we've talked about that. One of the things that's often forgotten is consider track on and track off. Whenever you have a side road that you're coming on, you're going to be bringing material, if it's not surfaced some way or have dust pallet put on it, you're going to be tracking dust onto that roadway. And when the cars come by or ATVs come by on that treated road, it's going to pick up the dust. They had a problem in Eagle River near Anchorage with that a number of years ago. They paved the roads. People were tracking the dust from the gravel road onto the paved road, and the speed of the traffic was casting that up and causing problems, and took them out of compliance with the dust requirements of EPA. So that they finally just paved about 50 feet each side of those on the gravel roads and took care of that. Now they paved them all, so it really took care of it. But think about that. You really want to do something about that. In Nome, you have a real problem on their paved roads. Nome, Bethel, Kotzebue, and Utqiagvik are all have the problem with track on under their pavement. In fact, if you look at them, sometimes you can't even tell it's pavement due to the track on. And so you're really not getting any dust benefit as a result of your paving activities. So you really want to try to minimize that. Chemical palliatives, which we've just kind of gone over very quickly in that, they're going to require periodic reapplication. How frequently depends on how you put it down, how much you put it down, and the traffic levels you're talking about. But you really the experience, and then we can talk about that one-on-one if you like. If you want some guidance on that, I'll be happy to give that to you. You might want to consider when you're using chemical pallets just to run a compactor over it. We find that a periodic compaction actually helps increase the life of those products because abrasion is a big issue for it. You start loosening the material up, and then it gets pushed off to the side by the vehicles. But if you compact it periodically, that seems to help that a little bit for that. And then again, changing driver behavior, we want to make sure that we drive in a way that does not abrade the surface any more than we have to. And then we'll talk more in phase 2 about pavements, but they do require some annual maintenance as well, pothole patch or crack patching, those kinds of things. But I know many of the communities, a few of the communities that have been paved really enjoy it because they're able to use skateboards, bicycles, and those who are wheelchair bound really enjoy that, being able to get out on that, and mobility increases as a result of that. Some things to be concerned about. Some of these materials will actually get cast in the air over time because they coat the particles. You can get some runoff, so be aware of that and what materials are can be reduce your water quality. And there are a lot of tests that you can have run to take a look at that, and we can talk about that. The materials that are water soluble, when they tend to move upward into the soil and move to the surface. Salts are some of those, and some of them that are not soluble in water tend to leach downward. And the synthetic fluids and the asphalts are some of those materials that tend to move downward into the soil over time. As we say, there's some things that we need to pay attention to in that. One is where you're slowing down or speeding up. Those are high shear areas, which cause damage to your palliatives. and abrade the surface and loosen it. These are areas that you either want to apply more frequently or compact more frequently as part of that. And then we talked a little bit about track on. So we recommend that in the untreated streets that you actually treat a portion of it. 25 to 50 feet from the intersection is kind of a good rule of thumb for that purpose. Okay, there's a Forest Service guide that's out there. There is I think we can have a link to that. If we don't, Vicky, maybe we can put a link to the Forest Service guide that gives you some ideas of when to use it and when it's most effective. It's a bit dated in there, but at least for the class of palliatives you're looking at, it can give you some idea of which ones are most effective. There's a new one out by Dave Jones, who is at UC, University of California, Berkeley, not Berkeley, University of California, Davis. He developed a newer system in there, and I'm not going to go over this in any detail, but just know that it's out there, and I'll be happy to work with you if you want to look at some of these. And basically, you go on you pick numbers out of here and you put them into a matrix like this, and it will give you some idea of how which palette is going to work best for you. He does have an app on his website to look at that, and I'll try to look that up and put that on our website as well, so you have access to that. Okay, so let's walk through some of these and try to give you some idea of what when they're advantageous for you to use and when you might want to avoid them. Water, and we've already kind of gone over that. It turns out that water, the big problem with water, it works very well, but it does dry out fairly rapidly. And the hotter and drier it is, as this graphic shows, the more quickly the water dries out. And that stands to reason. I think we've all experienced that, but we can actually estimate what that time is by using this graph here. Water tracking salts, calcium, the salts that we've talked about as part of that. We like to use calcium chloride as much similar to sodium chloride that we're all used to, and but it's quite a bit stronger in that. If you've ever tasted calcium chloride, you're not going to forget it. It's very bitter tasting in that. But sodium chloride on our tables, they actually coat that in sugar so that it doesn't taste so bitter. But we also use it in de-icing and anti-icing as well as a dust palliative. And basically, it has a strong affinity to water. If you set that out on the table in a humid area, it's going to grab water and it'll become wet as a result of that. And we're using that to our advantage in the soil. It's attracting water into the soil, and that helps hold the water together. Remember that plasticity index we were talking about? That's a function of water, so we want to keep water in the soil, and that helps hold it together and reduce it also coats the fines and keeps the dust down. As I say, it's just basically holding all that together. It's one that's used in Alaska most commonly. Even in a lot of the villages are starting to move more and more to calcium chloride for that. And it's very easy to put down. We'll talk about that, but it's also works really well. It does require fines content, somewhere between 10 and 14. If you don't have enough fines in there, it's not going to work very well for you. And if you put too much fines in there, when it gets wet or rains, it's going to become slick and it's not going to and sticky, and so it's going to get tracked around quite a bit. If you're in an area that has a relative humidity below about 35%, it's not going to work very well. So really, in the late fall, when you're starting to get into freeze up, I know Nome has had a real problem with calcium chloride because in the winter time before the snow falls and get a snow cake on it, and the relative humidity drops below about 35%, they start getting a lot of dust as a result of that. So you gotta, that's just something you gotta be aware of. And then if it's a problem for you, we might want to look at something else. And it can, as I mentioned, it can be slippery, especially high fines content. Has a bitter taste. It's a mucus irritant. Your eyes and your nose are going to burn if you get uh, if you breathe it. It's not a long-term health issue, but it is going to be a bit unpleasant for a period of time after you have been exposed to it. We'll talk about that in quite a bit more detail. And if you've used too much of it and it gets washed off into water bodies adjacent to your roadway, it can cause water quality issues. Uh, we use it because it is most competitive. It requires minimal equipment, and the workforce development is easy to do. So that's the reason we tend to use it. Uh, it's it is the second most commonly used. Um, and it's very cost effective. I know DOT is paying about $7,000 a mile, a lane mile to put it down, versus synthetic fluids, which the last time I looked was about $20,000 a lane mile to put down. Uh, and so and it takes a little bit more equipment. Um, you want to make sure you define your project limits, and this really applies to all of our palliatives, establish your drainage, and make sure that you can get the water off. We want to make sure we got to, if we need to, we refresh our surface course in that. And ideally should be about 4 inches thick for grading purposes. Establish your line and grade. And if you have silt or clean sand, calcium is not going to necessarily be a good choice for you. Uh, we can apply calcium chloride in a couple of different in a couple of or several different ways. We can topically apply it. Basically, we're going to create we're going to put it right on the top within the top couple of inches of the road. We can apply it as liquid or solid, and we can mix it into the soil either in the form of a liquid or soil. If we can mix it in, we're going to mix it in the top 3 to 4 inches. But no matter what, how we're going to use it, we really want it to be 1 to 1.5% by weight in there, and that's not very difficult to calculate. But that's you're going to use that in order to figure out how much you need to apply, as well as how much you need to order. Required equipment, pretty minor. If we apply it as a solid, we basically need a grader, some way to spread it, a water truck, and ideally we'd like to have a compactor to compact it when we're done. Not absolutely necessary, but it's to your advantage to do that. If we apply it to liquid, um, a little bit different equipment. We're going to need a grader, a water truck, and a compactor is optional. And depending on how you get it, if you get it in the super sacks, you probably want a forklift so you can lift it up and put it into the truck. Otherwise, you might want to consider ordering it in bags so that you can handle it. Steps to a solid application, we're going to shape the road, and then we're going to compact it, and then we're going to loosen the upper 2 inches, and then add the salt, water, and then recompact. And I'm not going into great detail, but that's really all that's involved. You can probably do at least a mile a day with the equipment you have in the villages. If you're going to mix it to full depth in there, we're basically going to windrow to the center line, add our salt to the windrow, blend it by moving it back and forth a few times, shape it, water, and compact. It's going to take you a little bit more time to do that. The advantage of going 2 to 4 inches in most of your communities, you could probably get 3 to 4 years before you have to reapply. And if you do reapply, you're probably just going to add a little bit to the surface and make it easy. But it's going to cost you more in the beginning, but it's probably going to be a little bit cheaper in the long run. So it is a means of doing it, but that's going to be a function of your desires and your budget. If we want to add brine to the surface, and I'll show you a curve or some graphics in a moment to show you how much water to salt you need to put in there. But it's actually a little bit easier. You're going to shape a road, apply the brine as we see here with this water truck, and then compact that if you've got compaction equipment. It's actually going to be quite a bit faster for you, but It also, if you're going to blend it 2 to 4 inches, we're going to loosen the roadway to depth, apply the brine, blend, shape, and compact. So it's going to be a little bit more effort, but you can do it that way. Talking a little bit about worker safety. One, you want to make sure you've got coveralls for all of your folks, coveralls, gloves, safety vests, and glasses for them. Calcium chloride is a strong irritant, and you want to protect your workers as well. Make sure they got plenty of water because that, they could breathe in a little bit of that dust, and you want to make sure that they stay hydrated and get that washed through their system. Showers at the end of work shift, rather than having them go home and try to shower, it's better to have them shower before they leave work and get the salt off of them, and that way they don't have to take their clothes home with them, and expose their family to that salt. Consider providing hand creams and body lotions, so that they should actually at the end of each day use those body lotions and hand creams to rehydrate their skin. Equipment care. You want to prevent corrosion by washing the equipment at the end of every shift. Thoroughly wash them. Use pressure washers to do that, and take the time to get that cleaned up pretty well. Thoroughly rinse brine tanks. You don't want those rusting out. Some people are going more to the plastic type of brine tanks rather than the metal ones because they don't corrode. And then lubricate your equipment more frequently in order to keep those lubrication points from corroding. As I said, you want to use about 1.5% to that. And so if you've got a surface course, which generally is going to weigh about 3,500 pounds per cubic yard, so that would calculate out to about between 35 and 53 pounds per cubic yard, adding that material. So if you had just simply estimate the number of cubic yards that you're going to be treating and use those values, it makes it really easy to calculate. And what I've done is I've given you a table here. There's 2 ways you can get it. You can get it flakes, pellets, or liquid. And you can use this table to figure out how much salt you need to treat a square yard of material topically. That's 2 inches deep. So and then if you want to mix into a tank, here is a graphic that you can use. You just knowing the amount of water that's in your tank and the amount of calcium chloride at 97% concentration for pellets, and flakes, you're going to get 80%. You just go over and pick it up. So if you want to treat 4,000 gallons of water using flakes, you just go up there to 4,000, go over, and you're just shy of 1,500 gallons of calcium chloride. Okay, so some parting thoughts on calcium chloride. There are several ways to apply it, and choose a way that fits your desires and your equipment and your workforce best. They're all effective. They all end up with essentially the same result. It's just finding the way that fits the equipment and workforce that you have best. Plan where you're going to apply it in advance, and from there, you can focus on the higher traffic areas, the places where people live, as we've talked about before. Plan early, order early. It takes a while to get here. You may be in a situation where you are ordering here in the next month or so, or month or two, in order to get it on the barge and to get it to your community so that you can store it over the winter to put it down next spring. So look at your logistics and see what fits. If you do order it and overwinter it, make sure you cover it thoroughly. I suggest at least a double wrap of tarping in order to keep the snow and water out of that. It's really a pain in the neck to have to go out there with picks and break that stuff up so that you can use it. Uh, if you need bags, if you can't handle super sacks, grab bags in that, and it works right. As I said, keep it dry and protect your people and equipment. Vicky, do we have any questions so far?
No, nobody has posted in chat or raised their hand
Okay,
that I can see. And if anyone wants to, go right ahead. I'll remind everyone that our part 2 of the dust management series webinar series will be on May 23rd at 1 p.m., which is a change from the originally sent out date.
okay. Okay, the other popular one that's being used in Alaska are the synthetic fluids or the synthetic oils, especially on our airports. Those are generally proprietary formulations, so we'll look at that. It's just basically a petroleum product with all the aromatics removed. Um, they do meet all of the EPA and DEC toxicity requirements, so we don't have to worry too much about that. They're naturally clear, but unless they have additives. I know Midwest Industries put tall oil in theirs, which makes it kind of a blackish color. It's not making it any less safe. It's just they've chosen to put something in there. They are non-corrosive, but they're probably oh, 2 to 3 times more expensive than calcium chloride. But the nice thing about it is you can store them to -40 or -50, and they work just fine as a result of that. You can apply it with some minimal equipment. Here is in Ruby, where it was applied. We were able to apply it with a very simple pump with a trailer with the tote on it and pulled by ATV. This one's a 4 by or a 4 by 6 in there. But you have to do it right. This is not a good thing to do. You're not getting out of this a very good uniform. It's kind of puddling up. And this is what that airport looked like when it was put down. The contractor put it down, and that did not perform very well at all. In fact, the contractor had come back and completely reapply uh, the synthetic fluid to there. Uh, and then this is another runway. I forgot which community this is in, but they used the system we used in Ruby and was able to get a nice uniform application. You can either build your application system yourself. We can provide you with the materials and the approach if you like, or Polar Supply does sell the whole system for you if you just want to buy it. And uh, about 8 years ago, it was $12,000. I'm sure it's closer to 20,000 now. Um, there are several types out there of these synthetic fluids. Make sure that your products have been tested. When that we can provide you with the test methods for that to make sure to do it. So you really need to do your homework to make sure that you've got the right products. Some of them that we have worked with, I can tell you whether they do or don't apply for many of them. So if you ask, I'll be happy to provide you that. The application rates, you want to be careful. Too much is wasted uh, expensive products. But if you don't put enough on there, you're going to get poor performance. And so you want to try to get that. Um, for synthetic fluids and many of the palliatives, we do have a test method, and I'll show you that in a few minutes, that allows us to test it with your soil before you put it down. And with the system that we got now, we can actually go out and test on site to see how well it's working. And this is what it looks like. We call it the mini dust column. As you can see there on the right, we basically put some soil in that little hole at the bottom, and we have an air pressure, and we puff that soil up there, and we use that dust track that's sitting off to the right side to measure how much dust is in that column over a period of time, and from that, we can make an estimate of performance. On the left-hand side is what it looks like. It's in a rifle case, and we can actually just grab that thing and head out the door and actually measure the dust that's coming off the road as well. Um, to, this is some of the testing that we've done. And the reason I put this here is to give you some ideas of what ranges synthetic fluids work best. An application rate of between 30 and 40 seems to be right. On the right-hand side is the percent reduction compared to untreated soil. At 30 square feet per gallon, we get about 92% reduction, really good reduction. At 40, we're getting about 85, which is the DOT specification that they're using at this point in time. But if you get lower than that, you start getting below what we consider the minimum performance range. So if somebody comes to you with some of these materials, I would suggest, and they say it works well, I would suggest you call their bluff and say, show me the test, or require that that it be tested by the university here. And we'll be happy to work with them to they'll pay for it, but we'll make sure that those materials will work properly. But most of the materials that we've seen out here work reasonably well in 30 to 40 gallons per square feet per gallon. But once you get above that, they're not working very well. So I would tend to avoid that. Synthetic fluid application, as I say, we don't want to use water trucks. We found that spraying it like in a fan like we're showing here tends to work better. We also have found that you're usually better off putting it down in 2 or more passes. What we find if you try to put it down in one pass, it sets on the surface and can run off or be tracked onto your vehicles. And so we generally put it down in two sprays and let it soak in between, and that seems to work a lot better for us. As I say, recompact everything, protect it by controlling your aggression as you're looking at now. Again, the fines content is critical for that. This is another device that we use to test the roadway or the effectiveness of your palliative on the road. We can also use the dust column we showed before, but basically what we're doing is measuring the dust that's coming off the tire in the ATV. So we can come out with that gray box and just bolt it to one of the ATVs in the community, drive up and down the road and measure the dust that's coming off. As I say, the system is very versatile. We can put it in the back of a pickup, on a flatbed, behind an ATV. There's a large number of ways we can put it on. Some of the reasons we've had poor performance with some of these materials, synthetic fluid, is due to low fines. Doesn't work well. In some cases, the material is too dense, and so we don't get penetration of those materials. And we can look at the gradation now and determine whether that's going to work. Poor weather, we've seen rain right after it and just wash it off, or we put too little material in there. So we're getting close to the end. Here is our website. As Vicki said, we've got a lot of good products on our website, not only for dust, but a number of other areas, as well as all of our webinars, so that you can go back and look at that. So if you want to see this again or share this with any of your colleagues, you can go to this website and gain access to that. Okay. There's been a number of people involved in our research, and we always like to acknowledge their help, including DOT and Federal Highways, DEC, some of the vendors of the materials that helped us along the way. Okay, so just to kind of give you what's coming up next, we're going to talk about the use of clay additives to our roadways to help improve the performance of or to create a surface that is dust-free. Some polymer stabilizers that we've been working with, and they're gaining in popularity. Chip seals, recycled asphalt, and we'll go all the way up to talking about hot asphalt pavement. So with that, if there are any questions, I'll be happy to try to answer them.
You can post in the question and answer. You can raise your hand, post in chat. Anything is possible. The slides will be made available on the Alaska TTAB website, along with a link to the recording of this webinar. This webinar will also, because this webinar will be posted on the AIDC YouTube channel under the Alaska TTAB playlist. There aren't any questions. I'm going to stop recording. Oh, is there a spec sheet to build a do-it-yourself pump?
There are, I'll have to go look it up for you. Our DOT has one. It's pretty simple, so I'll see if I can't find that for you and get it posted. Thank you, Brandon. Any other questions?
All right, I'm gonna
All
stop
right,
recording.
if you think of one later on, there will be the next webinar. You can ask it then, or just drop us a line, and we'll be happy to answer any questions that you have.